Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to my YouTube channel. My name is Aliyah Rumini Larasati, with my ID number is 4192111004. Today, I will continue the discussion from the previous video. Today, I will explain what I know in the chapter 5, namely about Babylonian mathematics development. In this chapter, I will discuss 6 sub-chapters. The first one is about development in the history of Babylonian mathematics. The second one, Babylonian number system. The third one, advantages and disadvantages of the Babylonian number system. The fourth one, invention related to Babylonian mathematics. The fifth one, legacy of Babylonian mathematical history. And the last one is Babylonian mathematical figure. Okay? I will explain the first sub-chapter is about development in the history of Babylonian mathematics. Babylonian mathematics is all mathematics developed by the Mesopotamians. Now, we know as Iraq, from the beginning of Sumer to the beginning of Hellenic civilization. Named Babylonian mathematics because of the Babylonian region's primary role as a place of study. In the age of the Hellenic civilization, Babylonian mathematics combined with Greek and Egyptian mathematics to give rise to Greek mathematics. Then, under the Islamic Caliphate, Mesopotamia, especially Baghdad, once again became an important center for the study of Islamic mathematics. Contrary to the scarcity of search on Egyptian mathematics, knowledge of Babylonian mathematics was derived from more than 400 clay tablets since the 1850 s. The slabs were written in the cuneiform while the clay was still wet and burned in a furnace or dried in the hot sun. Most of the known clay tablets date from 1800 to 1600 BC and cover topics of fraction, algebra, quadratic and cubic equation, and the calculation of regular number, multiplication, inverse, and twins primers. The slab also includes a multiplication table and a solution methodilinear equation and quadratic equation. The Babylonian plate gives an approximation to 2 which is accurate to 5 decimal place. The second subchapter is Babylonian number system. The Babylonian number writing system was known as cuneiform from the word kunes, which means slice or split, and the word form, which means form. Babylonian writing and numerals are often referred to as cuneiform because they are shaped like nails. Babylonians wrote cuneiform using an elongated triangular shaped stick. By pressing it against a wet clay plate to produce a tablet triangular, the precision resembling a nail. Unlike those of the Egyptian, Greek, and Romans, the Babylonian numbers use a correct place value system, in which the numbers written in the left column represent in the large values. The Babylonian civilization in Mesopotamia replaced the Sumerian and Akkadian civilization. In the form of number used, the Babylonians inherit the idea from the Sumerians, namely the sexagesimal number system, with base 60. Due to the Babylonian prominence in astronomy, the 60-base system of calculation is still in use today. It is provided by the derivation of number 60 seconds for 1 minute and 60 minutes for 1 hour. A reason why the number 60 is used is because this number is the smallest number that can be divided by the first 6 digits, namely 1, 2, 3, 4, 5, and 6. Another reason is that the number system most widely used by humans today is the decimal system, which is a system based on 10. The Babylonians wrote cuneiform using an elongated triangular. The following is an example of writing symbol for the Babylonian numerical system. The Babylonians used 1 to represent 1, 2 to represent 2, 3 to represent 3, and so on, up to 9. However, they tend to arrange symbol into net fields. Once they got the 10, 3 were too many symbols, so they tried to make different symbol. 11 is 10 and 1, 12 is 10 and 2, 20 is 10 and 10. For symbol 60, it seems exactly the same as symbol 1, 61. It's a combination of the symbol 60 and 1, which therefore looks like 1 and 1, so on. And then the third subchapter is about advantages and disadvantages of the Babylonian number system. The first one is advantages of the Babylonian number system. The advantages in Babylonian number system is the first one is recognizing building forms. The second one, determination of the square root value. The third one has demonstrated the Pythagorean theory. And the last one, measure an area and volume. And then the disadvantages of the Babylonian number system. First, don't know zero. Second, not familiar with commas to make decimal number. Third, don't know the negative sign. Fourth, addition, subtraction, multiplication, and division are still unclear. And then the next subchapter is inventions related to Babylonian mathematics. The first one in geometry field. Geometry was used by the Babylonians from 2000 to 1600 BC. They calculate the circumference of circle using 3 times the diameter. The area of the circle is used 1/12 of the square of the circumference with 3.14. The volume of an upright cylinder is calculated by multiplying the area of the base by the height. Number 2 is algebra field. Around 2000 years BC, the development of algebra is not only able to solve quadratic equation, but also discuss solving third and fourth power equation. It can be seen that there is a relic in the form of tables whose contents are in the form of tables of square and cubes of number 1 to 30 and combination of N3 and N2. Number 3, sexagesimal number or base 16 number. Babylonian mathematics was written using the sexagesimal number system. Because of its superiority in the field of astronomy, the 60-bit calculation system still exists today, namely by recognizing the use of the number 60 seconds for 1 minute and 60 minutes for 1 hour. The weakness of this system is that there is no zero symbol. The symbol 1 and 60 are the same. In the case, the space bar will also not be able to help explain whether the symbol is 1 or 60. Okay, the next subchapter is Legacy of Babylonian Mathematical History. The cuneiform script was used in the manufacture of the Babylonian letters. The plates are written while still wet and then dry or burned. There were 4 blackboards found, namely, the first one is YLYBC in 7289. This is the picture. The YLYBC board is a board on which is a diagram drawn in the shape of a rectangle measuring 30. The Yale manuscript contains N3 plus N1 tables for solving equations, including cubic equation that lead to stimulation equation leading to quadratic equation. Number 2, Plim Pattern 322. This is the picture. Plim Pattern 322 is a board numbered 322, which is the result of browsing ancient Mesopotamian manuscript written by G.A. Plimpton containing mathematical problems. The manuscript contained a mathematical table from the period between 1900 until 1600 BC. The Plimpton manuscript is in the form of the table consisting of 4 columns and 15 rows containing Pythagorean triple number. Number 3. Susa board. This is the picture of Susa board. This board shows how to calculate the radius of a circle through an equilateral triangle. In this Susa board, there is a triangle ABC with a center of the circle at point 0, and there is a line AD containing point with line BC. From the figure, we can see that triangle ABD is a triangle on the right side of circle. Number 4. Digital board. This is the picture of the digital board. This digital board displays a geometric problem that asks for the dimension of a square whose area and diagonal are known. Okay, and then the last subchapter is about Babylonian mathematical figures. The first one is King Sargon. King Sargon was the leader of the Akkadian nation. In terms of culture, the Akkadians imit the advanced Sumerian culture, so that the new culture was developed called as the Sumerian Akkadian culture. At this time, found the calculator abacus. The second one is King Hammurabi. King Hammurabi was the greatest Babylonian king. King Hammurabi is famous as a legislator. This is thought that in the past, the laws that were issued were made into characters and shown to the general public for approval. So, laws are made by the government slowly to suit its own opinion. In this sense, the character made by King Hammurabi, commonly known as the Hammurabi Charter, can be considered a precursor to the official legal system as it is currently in effect in modern society. The next one is Diophantus. Diophantus is a father of algebra. For the Babylonians who developed the concept of Babylonian algebra, a Greek mathematician living in Alexandria. Diophantus' major work is in the form of a book on arithmetic, the first written book on algebraic system. The preface portion of Diophantus' arithmetic contains the solution of approximately 130 problems that yield first-order questions. And then the next one is Babylonian science. Babylonian science discovered the determination of the value of the square root and even demonstrate the Pythagorean theory. Long before Pythagoras himself came up with his theory, and this was proven by Denis Ramsay, who translated an ancient record dating from 1900 BC. And then the last one is Otto Nengori and V. Theory Dangin. They were found much knowledge about the contents of these mathematical tables on older than 1935. Since the work on interpreting this table is still ongoing, new and equally interesting discoveries are very likely in the near future. I think that's all I can explain in the chapter 5, namely about Babylonian mathematics development. If I have something mistake or something wrong in my pronunciation, please apologize me. And then thank you for your attention. Thank you for watching. And then wassalamualaikum warahmatullahi wabarakatuh. See you in the next video. Goodbye.